Alright, so today we're going to be solving linear equations by substitution. Remember, when we're solving linear equations, there are two straight lines intersecting, and we want to know that intersection point, the x and the y coordinate. So in doing so, we've done this before graphically, but there are methods where we don't have to use a graph, such as the substitution method. So when we're doing the substitution method, it'll be an algebraic way of actually finding the same x and y coordinate we would find as if we would have been graphing it. So let's look at the first example. Example 1a. The equations will be y equals 2x minus 4 and 7x minus 2y equals 5. So these two equations will form a straight line and they will intersect. However, I'm not going to graph them. I'm going to do this algebraically. This is called the substitution method, but I call it the nickname method because when you substitute something for something else, it's pretty much like a nickname, right? You have a name for something that represents the same thing as another name. So first step is to find an isolated variable. I found y, which is isolated here. And I'd like to see this as y having a nickname. And I will box in what I call the nickname. The nickname because 2x minus 4 is the same thing as y. So instead of saying, hey y, what's up? I can say, hey 2x minus 4, what's up? Just like people say, hey Blanca, what's up? Hey Miss Flores, what's up? I'm still the same person regardless of whatever name you give me. So they're telling you here that these are the same. So I'm going to use that term as I am saying this second equation. So it would say 7x minus 2, but I'm not going to call it y this time. I want to use y's nickname. 2x minus 4 equals 5. And when I do that, it's going to look a little more complex, but we can also simplify that, okay? Now, the reason we do this, if I were to ask you to solve this equation, as we usually would, you would draw the line, and then you decide on getting your variable by itself. But you can't do that because you have two different variables. And it'd be like, wait a minute, make up your mind. Which one am I going to solve for? There's two of them. So it's not really possible, okay? So we're going to do this substitution trick, and you'll see how that fixes that problem. So it's going to become 7x minus 2. Again, I'm not going to call y by y. I'm going to call it by its nickname, 2x minus 4 equals 5. Right? So y's nickname is 2x minus 4. Okay? I did not change the equation. I am actually just substituting the nickname for y in there. Okay? So now, notice I don't have a y in my equation anymore. It's all x's. So now I can focus on finding x. So in doing so, we're going to distribute. So negative 2 times 2 is negative 4x. And negative 2 times negative 4 is positive 8. 7x is still there. And 5 is still there. And now I'm still solving, but not yet. I'm in the process of trying to make this look simpler. And in trying to make this look simpler, I can put together some like terms. This one and this one. And when you put these together, we get 3x plus 8 equals 5. And now I'm trying to solve it now. Inverse operation of addition is subtraction. So subtract 8. And then now I'm going to get 0 here, negative 3 here. I'm going to bring down this 3x. Almost there. To eliminate that 3 that's with the x, the inverse operation of multiplying by 3 is dividing by 3. 3 divided by 3 is invisible 1. And negative 3 over 3 is negative 1. So now, I did say we're going to have a point as our solution. And we just found our x coordinate, negative 1. All right, now I have to find my y. So looking at the original problem we were given, they tell us right here what y equals. So if I want to know this y, it's right here. So you most likely will always go back to the nickname. Y equals 2x minus 4. So that's what I'm going to use. I used a bubble for my x because I do know what my x is and I'm going to be plugging it in. And we just did the math and we found that x was negative 1. So now my solution is going to be 2 times negative 1 is negative 2 minus 4, that's negative 6. Y equals negative 6. So this is my solution, the point where those two lines intersect. Right, so let's do one more. Y equals 2x plus 3. And y equals 5x. Now notice this one has two isolated variables. So in this case, it's like saying Miss Flores equals Blanca and Miss Flores equals Estella, my middle name. Some people call me Blanca, some people call me Estella. So if I say Miss Flores is Blanca and Miss Flores is Estella, I can also say Blanca is Estella. We're the same. So these two are equal to each other. So you can do it that way, or you can do the process of identifying a nickname. In this case, it doesn't matter which one. So I'm going to call this one the nickname. So 2x minus 4, I'm sorry, 2x plus 3 is the same as y. So now in this equation, I'm not going to use y. I'm going to use 2x plus 3, the nickname for y, equals 5x. Okay, so I could have put parentheses, but there's nothing to multiply. Now we're going to solve for x. So again, let me go back. Using this nickname in this equation is the same as saying, hey, wait a minute, if they're both equal to y, then they're both equal to each other. And that's what I wrote here, equal to each other. So you get the same thing, either plugging in the nickname or recognizing that they're both equal to the same thing, so make them equal to each other. Right? So let's go ahead and solve this for x now. I'm going to put my x's on this side and my numbers on this side, constants. This was the story I told a while back about all the numbers on one side, x's live on the other. So the only out of 1, 2, 3 terms, the one that's in the wrong place is this 2x. It should be over here. So the opposite of a positive 2x is, oh, that's not dark, is a negative 2x. What you do to one side, you do to the other. That's gone. So now I have just 3 over here and a 3x over here. I'm trying to get x by itself, so we're getting rid of that 3. Opposite of multiplying is dividing. That's invisible 1x. And then here we get 1. So x is 1. And now I need to find my y. And notice up here we have 2 to choose from. The bottom one is simpler, so we'll use that one. Y equals 5x. Okay, we just found x and we were trying to find y. So, looking on your paper, do you see anything that says y equals? Right here. So I'm going to use it to find y. And I'm going to plug in that 1 that I got. And 1 times 5 means that y equals 5. And that's my solution where these two lines intersect. All right. So now let's just narrow this down in what kind of steps did we do. So the first thing if we just want to narrow down what the process was. First thing we did was we located an isolated variable. Now, the reason why we located an isolated variable, right, because you wanted to find the nickname. So I'll just put on here nickname. And get your nickname. Okay. And then second thing we did was we used the nickname in the other equation. I'll put it in quotations. Okay. So once we found our isolated variable, we identified the nickname, and then we took that nickname and used it in the other equation. Then the third thing we did is we solved it. All right. And once you got your first variable all by itself, you got your answer, we did the fourth thing, which was plugged it back into the nickname. Right? Now, just remember, these are the steps for my particular technique. These aren't necessarily you're going to see in a textbook. It'll just say substitution, this and that, but the nickname is the same idea. So once you plugged your solution into the nickname, and that piece was when we took our nickname here, and we plugged our solution back into our nickname, you got your second variable, and you're done. Plug solution into nickname, and get second variable. Okay. All right, so for example 2, it's a word problem, but we're just going to bullet point the important facts so that we don't have to write so much. First fact is that it was 50 total burgers purchased. All right, and then the next thing we're told in the problem was that they spent a total of $90. The next thing we know is that it was $2 for each turkey burger. And then we were also given that it was $1.50 for each veggie burger. And the question is, how many of each burger was purchased? All right, so we do not have equations to solve, but we are going to have to create our own equations. By looking at this, something should stand out telling you that when you see a problem like this, it is a system of equations. What about it tells me it's a system of equations? Well, I see two totals. Two totals. That means two equations equaling two different numbers. One equation is going to be a total of 50. Another equation is giving me a total of 90. So that's the key idea there. So solution is going to look like this. First equation, it's talking about a total of 50 burgers. Notice I wrote equals 50 burgers because I already know that if this is a total, it's the answer to something. And then the other one that I have a total of is $90 spent. And notice that also goes at the end of an equation because I wrote equals 90. Because I know it's a total, it means something is going to be done in a calculation that's going to give me 90. Now, what am I adding up that's giving me 50 burgers? Let's look at the information given. Think about it on your own. What together is giving me 50 burgers? Right? You should have been thinking the total turkey burgers plus the total veggie burgers was 50 burgers. So turkey burgers plus all your veggie burgers came out to 50 burgers. Now, how am I collecting $90? How did I total that expenditure? What came out to $90? Think about that one. What was I spending on? What was I buying? Okay, you should have said all of the money spent on your turkey burgers plus all the money spent on your veggie burgers equals a total spent. Well, let's focus just on turkey burgers. If we know how much each turkey burger cost, what expression would be used to find out the total spent on just turkey burgers? It should have been 2 times T. Because if it's $2 for each turkey burger, if it was 2 burgers I purchased, it would be $4. If I purchased 3, it'd be $6. If I purchased 5 turkey burgers, that would be $10. So the way you calculate your total is the price for each one times how many you're buying. Plus, what expression would represent the money spent on just veggie burgers? And we're thinking 150V. I could put the 0, but because this is going to be in our calculation, we'll just put 1.5V, which still represents $1.50, okay? So why? Because if I needed to purchase 2 veggie burgers, I'd multiply 2 times 150 and I would spend $3. Okay, so that's how you're calculating each expression for how much was spent. So now I have 2 equations. And if I'm going to use a substitution method, I need to isolate a variable. I do not have a variable that's all alone, but I could get one to be isolated. So over here, I'm going to show you how I isolate, let's isolate the V or the T. So I start with T plus V equals 50. And I want to get T all by itself. So I'm going to subtract V from both sides. Now V is gone here, and I end up with T equals 50 minus V. So now I have a nickname. So this is the nickname right here I'm going to use. 50 minus V is my nickname for T. Okay? So now I no longer need this equation. I'm going to use this one instead. Okay? I rearrange this equation by taking this V, subtracting it onto the other side. So let's rewrite this system of equations. We don't really have to, but just so that you see. So now I'm going to have T equals 50 minus V, and 2T plus 1.5V equals 90. Okay? So I just rearranged the first equation so that I will have a nickname. And now I can say, this is my nickname for T. And just like before, it's going to go in here. So let's go ahead and put that. So we'll have 2T plus 1.5V equals 90. All right, so I'm not going to call him T. Instead, I'm going to call him by his nickname, 50 minus V. Okay, so now we're going to go ahead and solve this as we would usually. And the first step would be to distribute. 2 times 50 is 100. 2 times negative V is negative 2V. Plus 1.5V equals 90. All right, and now, combining like terms, negative 2 and a positive 1.5 leaves me with negative 0.5. And the way I think of this easier is if you have negative $2 and a positive $1.50. You owe $2, you pay back $1.50, you still owe 50 cents. Equals 90. And then I'm going to subtract 100 to get V all alone. I have negative 0.5 V equals negative 10 divided by negative 0.5. And V equals 50 cents goes into $10 20 times. And negative divided by negative is a positive. So there was 20 veggie burgers. And if there was 50 burgers altogether, you can go back over here. 50 minus 20, and means our turkey burgers equals 50 minus 20 turkey burgers. I'm sorry, 20 veggie burgers. So now we have 30. So 30 turkey burgers. There you go. So 30 turkey burgers and 20 veggie burgers.